I'm Paul Gowans from JDSU. Today I'm going to be talking about cell site evolution and LT evolutions and the implication on field technicians for turning up and managing cell site technology. So my name is Paul Gowans, I'm from JDSU. I'm going to talk about, I guess, two areas, cell site evolution and LT evolution, which are really kind of evolutions going hand in hand but getting driven from different directions, but have implications on both kind of turning up cell sites and managing cell sites. How difficult can it be to do wireless, right? You know, it's over there, so it must be easy because you don't have to put a lot of wires in. But of course, we all know in the industry that having no wires has implications on what you have to do in terms of the kind of complexity. I do want to just say this is what's driving cell sites at the moment, right? It's not whether it's LT or LT Advanced or MIMO or broadcast, it's what users are trying to do on their phones. And this is really what's having the major implications on capacity and coverage. You know, it's how many people want to do email or Snapchat or YouTube or Skype or whatever else everyone wants to do all the time, anywhere they are. And that's really, at the end of the day, what's kind of driving it. And I think sometimes you get kind of lost in the, the technology components and forget actually what the purpose of the network infrastructure and architecture is. At the end of the day, it's for people to get access to their apps on their mobile device and devices. And of course, that continues to explode as we move from kind of just human interaction to machine interaction. So the two things I'm going to talk about, as I say, are going to be what's happening at the cell site side, and also aligned with that, what's happening around LTE, which is hand in hand. So cell sites are evolving. You know, we're moving away from what has been a kind of traditional environment with macro sites to whether it's small cells, DAS, HETnets, Cloud RAN, Wi-Fi integrated it, and getting back to the reasons for driving this kind of broader architecture is the coverage and capacity needs for people to get access to their apps on their mobile device. The other area is this kind of whole thing about RF and fiber, almost kind of two worlds colliding at cell sites. You know, we're now putting fiber to the antennas, we're putting remote radio heads in. CPRI, which I'll touch on a bit more in a minute, is coming to play much more at fiber sites. People don't necessarily want to kind of climb towers to manage and troubleshoot issues, so I'm trying to kind of minimize that. But this kind of whole, RF world and fiber world coming together, RF engineers need to learn about fiber, fiber engineers need to learn about RF and the implications of those. And then the other thing is, of course, is that we're no longer just talking outdoor. There's a lot of indoor activity going on. DAS, distributed antenna systems, get involved here a lot, of course, with Wi-Fi integration, small cells. People want coverage in building. I was at an event recently which actually was around VoLTE, Voice over LTE, and ironically, the place we were in had absolutely no mobile coverage at all, because we were kind of downstairs in the basement, which is, and it's people go crazy with that, right? Because there's no coverage. So this outdoor-indoor thing is an important one, and also managing that, right? Macro ingress with kind of indoor sites is a kind of key issue where you want people on, for example, the indoor system, not connected to the outdoor system. So how do you kind of manage that? Where do you position cell sites? How do you know your apps and things are going to work just because the RAN's right? Let's not get confused about high power levels necessarily deliver a good service, right? He who shouts loudest doesn't necessarily get what they want. So that's really kind of what's happening in the cell site evolution. So if you kind of look left to right, traditional kind of macro sites, typical kind of copper front haul, conventional, lots and lots of these deployed, but moving towards the kind of distributed cell sites where you kind of break that connectivity with the radio heads and put the remote radio heads at the top of the tower, and typically these days put fibre in that front hall, and that's starting to gain a lot of traction at the moment. Moving towards distributed antenna systems, which is really like that kind of distributed cell site, but in a kind of broader play. Again, typically fibre used for the front hall, but the antennas are distributed. Whereas in the small cell, on the right hand side, you've got as its name suggests, kind of full node Bs or E node Bs contained as a small cell, but kind of distributed out. They may be backhauled to a macro site. Typically if it's a kind of metro environment, and certainly, as you kind of go left to right, you get the number of installations that are involved, but also you kind of think about the trend, where the trend is much more towards looking at how do you enhance coverage and capacity with things like small cells and DAS versus putting up a whole bunch of macro sites. And of course, as we see this whole world of kind of fibre and RF and cell sites all kind of coming together. So that's on the kind of cell site evolution. CPRI is an area that's gaining a lot of attention at the moment as a means of carrying RF over fibre at the front hall of your cell site. So getting back to that picture, the conventional cell site where you've got a coaxial feeder, a lot of advantages because you can easily get access to the RF on the radio for doing testing. Your base station analyzer can plug in there, and that's all great. However, with it being kind of coax based, there's implications for issues on that kind of coax link and connectors, etc., whether it's kind of PIM or loss or signal issues. So the kind of architecture that we kind of touched on with remote radio heads at the top of the tower, fibre as a physical connectivity in the front hall, CPRI being used to then carry the RF, right? So you basically you digitize the RF, package it in the CPRI protocol, and send it over the fibre links. A lot of advantages, of course, to that with using fibre around kind of signal issues and minimizing PIM and loss, etc. But one of the issues you have is that where you were typically connecting your base station analyzer or your cell advisor into the coaxial feeder, it's now fibre. So how do you connect in? The last thing you want to do is be continually climbing the tower, right? You want to be minimizing that as much as possible. So being able to, from a T&M perspective, both for install, turn up and deploy and manage, you want to be able to kind of connect in at that baseband unit as close as possible to the ground, right? You might still have to climb the tower to do some things, but you only want to do that when you absolutely have to. So CPRI is this industry agreement between many kind of NEMs and organizations kind of got together and said, what's the specification for this interface? And there's various parts to it which are kind of worthwhile having a look at, because these are kind of multiplexed over the interface. There's control plane and sync plane, which you kind of expect, but the important thing is this IQ data flow, which is in the user plane, which is where the kind of RF gets digitized, and you want to pull that out. So if you're doing analysis over the link, you want to be able to access both kind of control plane and user plane, to get kind of information out of it, and get access to the data again, preferably at the base of the tower, not at the top of the tower. Nice musical interlude added to the presentation. So one thing, so what this fibre thing, right, is I think really important when you're thinking things like kind of base station analyzer. I've got a picture of the JDSU one there, because typically, as well as doing what is your traditional kind of RF analysis, demodulation, distance to fault, standing wave, etc., you want to be able to do some optical capability. And of course, what you want to do is, you don't want to take 3 or 4 different instruments, you want to have that kind of integrated in one. So being able to do, for example, optical power in the same instrument, being able to do fiber tests so that I can actually do a, inspect before you connect fiber test on the fiber with the same instrument. Being able to save your results. This is another key thing, right? Cloud enabling your instruments. Typically when you're doing kind of cell site turn-up or management at the cell site, you plug in the thing, you get some results, you have a look, you throw the data away, you move on. More often than not, that data is very valuable, for keeping for future analysis. You might want to keep some data at a cell site turn up, and then 6 months later when something's gone wrong, you want to do a comparison. So cloud enabling and being able to save that data off is becoming more and more important. And finally, but certainly not least, is RF over CPRI. So being able to get access to that digitized RF signal that's carried over that CPRI fiber link within the same tool. And that's a great benefit for engineers who are going out troubleshooting and managing these cell sites and having that kind of all bundled in one. Small cells, there's a lot of talk about small cells. I think the deployment of them so far has been quite underwhelming. If you take away kind of pico cells from or femto cells from people's kind of homes, there's been, I think, a lot of discussion about the planning issues around small cells, right? If I'm going to stick them inside of buildings, I can't just screw them onto the side of a building. The backhaul to small cells, but that said, they will become more prevalent, right? I've no doubt about that a kind of combination of kind of macro DAS, Wi-Fi, small cells will become the norm. And of course, they're designed for kind of low power, small numbers of users, typically not moving around, but very much driven towards the kind of capacity requirements, particularly in kind of areas like this when you've got a lot of kind of tall glass buildings, bad reflections and poor signal. Again, people want access. It doesn't matter whether they're in the garden room of a club or whether they're in the cheese grater around the corner or whatever it's called. You want access, and of course lots of kind of glass and steel are not good environments for mobile. One thing, in fact, I can show you some of this capability in the solution I've got with me today, which is around Randovisor TrueSight. This is a tool that allows you to do kind of walk testing for signal and app testing, and again, it allows you to do it indoor, which is something that a lot of people want to do now. Kind of traditional ways of doing a lot of this testing would have been you'd get in a car or a van, you'd drive around, do drive tests, you'd capture the results, you'd post-analyze. Well, what a lot of people want to do now with a lot of indoor things around DAS, small cells, Wi-Fi, whatever that is being able to kind of do it in real time. Walk around a building, capture results, do it in real time, and do it preferably against a kind of map, like an IB wave file. And I mentioned about, for example, like macro ingress, being able to do the analysis around kind of how many times or what percentage of time you're on the indoor system versus you're connected to the outdoor one, because of course, depending on where you are, you can be moving off into the outdoor one when you don't want to be. This could be for a stadium, it could be for a mall, it could be for an airport, it could be for an office, it could be whatever. But a lot of interest now in being able to kind of do this and being able to kind of control it simply from, say, one tablet. So we've got a system, for example, where you can have multiple handsets, different operating systems connected to different carriers, running different services. So I can be doing a voltage service, I can be doing a FTP, I can be doing HTTP at the same time as gathering my RAN data. And that's really important because remember, way back at the start of this, I said, what's driving this need? The need is around apps. So being able to do kind of app testing at the same time as doing testing of the RF and the RAN is really important. You know, you can grab those metrics and use them together. Okay, so that's on the kind of cell site evolution. I'll just touch on the LT evolution, which, as I kind of said, is kind of carrying on at the same time. Carrier aggregation, you know, the ability, and I'll show a slide on this to multiplex channels together. MIMO, multiple in, multiple out, for, again, could be for capacity or coverage, but brings antenna complexity. Carrier aggregation and MIMO quite often go hand in hand, but don't have to be. LT broadcast, you know, you'll see with kind of LTE and 4G standards is, you know, they continue to advance. So LT broadcast is another component which is around you know, multicast broadcasting. You know, so instead of it being kind of single to single, it's single source to multiple destinations. VoLTE, I was recently just at a kind of VoLTE event. A lot of interest around VoLTE at the moment for delivering HD voice as a you know, IP-based voice service, much higher clarity, much faster connection time, but it needs to work, right, as a kind of end-to-end service. Although we did kind of talk about the demographics of of people using voice. You know, I did say kind of anyone under about, I don't know, 19 years of age doesn't actually use voice anyway, so maybe that's just for us, you know. Sometimes the demographic at these events isn't necessarily reflective of the people that are using the services, you know. Well, actually, so here's a question, right? How many people in this room use an app called Snapchat? All right, so one. So if I was in a room of like under 20s, right, everyone would put their hand up. Everyone would put their hand up. So we need to think about that when we're thinking about what apps and things like that are driving the need. And thank you for that. All right. I didn't plant him, by the way. All right, that was a find someone at least that uses it. By the way, I don't use it either, but I really should. Self-organizing, self-optimizing networks like SON, right? Again, a lot of discussion around that. Things like kind of automatic neighbor relation when you're looking at you know, dynamic architectures of lots of cell sites, particularly when there's lots of kind of small cells, where the cost and complexity of turning up and manage those sites is, you know, has to be considered because it's not a macro site anymore. So MIMO, again, you know, brings complexity to the environment. So you know, look, you know, the thing is, while all the cell site evolution's going on, you know, with small cells and DAS and Wi-Fi and indoor and outdoor, all this is going on at the same time, right? So this is why for the kind of engineer to turn up and manage these cell sites is becoming a more kind of complex world. But you've got MIMO for either kind of capacity need, where you're basically taking the user data and transmitting it from multiple antennas for kind of parallel communication, or coverage, where, you know, you're in a kind of environment like this where there's a lot of kind of tall buildings, and you actually send the same user data from kind of multiple antennas and they take different paths. You know, potentially doubling the capacity on spatial multiplexing. But again, you know, you need to be kind of managing that. I did mention that MIMO capability often gets used with LT aggregation, with LT advanced or carrier aggregation, and this is where you're taking multiple channels and multiplexing them together to create a bigger pipe. Now, typically, operators will not have contiguous, you know, components of spectrum. So you'll often have, for example, been able to connect kind of non-contiguous parts of the spectrum to form a bigger pipe. You know, if you want to get your 20 megahertz, you might have kind of 4 or 5 megahertz, but in different parts of the spectrum, and you want to kind of draw that together to produce one bigger pipe, and that can be used with MIMO to deliver a kind of higher bandwidth service. So carrier aggregation, a lot of activity going on at the moment. The operators kind of looking at carrier aggregation and broadcast, the LT broadcast stuff. I mentioned about VoLTE, right? Voice quality again. So now we're kind of at the, okay, so I've kind of got the underlying infrastructure in place and the kind of architecture's going, but does that necessarily mean that my services are all operating correctly end to end? How do I make sure that from the kind of handset I can do, VoLTE voice quality. How do I know that particular handset is better than another handset, or if I change the operating system, it's changed? So there's a lot of components of looking at voice quality around VoLTE, actually around voice in general. Things like, for example, like R-factor, MOS, you'll hear terms like kind of Polka and PESC as standards for assessing voice quality. But again, really important capability. Even if you're not charging for this, right? It might not even be a premium service, but if you're promoting it as kind of higher capability voice, you better be able to deliver and manage on it. So, solutions that do kind of deployment for turn-up and management, have to evolve and adapt, as I kind of mentioned, to a lot of change going on. And these things kind of going on in parallel. There's not kind of just a serial process here. So RF and fibre worlds colliding. That's a kind of given with things like kind of RF over CPRI. We have to be thinking about the cost of bringing sites into service, right? Particularly when we're dealing with kind of small cells and DAS and Wi-Fi. It's not the same kind of cost envelope of a macro site. If I'm deploying 10 small cells, I have to think of the kind of cost implications of that. As you see, LT is not standing still, right? Everyone kind of thinks, right, LT 4G, I need to deploy it. But now there's, MIMO, LT advanced, broadcast, RF fibre coming together, VoLTE service, etc. And that continues to add complexity. And you need tools to therefore basically help you with that complexity. And then, and just, that's good because last slide. And then just leave you with this thought. What about location? Right, this becomes a kind of key part of it, which is where do I put sites? Where are my hotspot issues? And think about, imagine if I could take my location systems data and integrate that with my base station analyzer, so I can send engineers out to the right place to go and solve problems. And that's something to consider as part of the whole evolution. All right. Okay. Thank you very much.
Do we have any questions?
I've got a question, Paul, on VoLTE.
Go on.
So currently, most of us use a thing called Skype, which is free of charge. What do you think the future holds as far as us being able to use VoLTE, with the HD, etc., in view of the fact that, as you said yourself, there needs to be sort of measurements to do with voice quality, etc., etc. So do you think I suppose my question is, do you think that service will be offered? Is it being offered at the moment? Or?
It will be. I spoke to a lot of operators recently in terms of the kind of rollout plans. So many of them have got plans for 2015. And they're at that kind of stage of kind of testing and pre-deployment. The comparison with something like Skype's an interesting one, because you're absolutely right to say, there's other services, app type services, over the top services versus kind of VoLTE. There's been some interesting studies recently done. If you read a kind of report from Signals Ahead, which does a kind of analysis of this, what they found was that as cell sites started to get congested, that's where things like kind of VoLTE really come into their own, because there's a lot of kind of capability in the LT protocol which allows that to guarantee service quality and bit rate, which of course you don't get from over-the-top services. And of course, as we know, a lot of cell sites are congested and you want to kind of maintain that. So VoLTE will come, absolutely sure about that. 2015 I think will be a key year for it. But you're absolutely right, it needs to be managed, right? It needs to work end to end. All right, thanks for that.
Thank you.
All right, okay, thank you.